Maybe before we start, we have this very nice Q&A chat function on the webinar for those of you who are online, where you can ask questions. And please do ask questions. I want this workshop to be a bit two-sided, not me giving a lecture, but you also participating, asking questions, and having some collaborative thing going. Cool. I see the sound is fine. So yeah, let's get started. For those of you who don't know me, my name is Silvin Willemsen. I just finished my PhD last month here at Aalborg University, where I made a lot of physical models of musical instruments using JUCE. So this is also why I'm giving this JUCE workshop now, both for you guys here and online. Maybe also before we start, for all of those online, we have here some students in the classroom who are following the Sound and Music Computing Master's program. And they're following this workshop as part of their sound processing class. So know that there's some people physically here, and those of you online, welcome as well. Great, so let's get started. What is JUCE? So JUCE is a framework for software development in C++, and it's specifically designed for creating audio applications and plugins. So here's an example of this, of something made in JUCE, where you can see there's a lot of sliders, there's some drop-down menus, there's some animations happening. So JUCE is very specialized in handling the audio and handling the GUI separately, and making sure that it's optimized for the audio thread in that sense. So maybe before we start, could I see a raise of hands for who has experience with C++? 1, 2, okay, so about half here. Maybe also on the webinar, you can raise your hand. Stefania raised their hand, there we go. Cool, okay, so about half of everyone has experience with C++. So in this workshop, I'm gonna assume that you have very little knowledge of C++, but at least some programming experience. Yeah, let's get going. So why would we use JUCE? We use JUCE to create real-time audio applications because avoiding latency is crucial. If you want to create a synthesizer, you don't want to press a button and then wait a second before your sound gets back, right? So if you want to make real-time or audio plugins, they need to be in real time. And as you guys here know, MATLAB is not very good at real-time stuff. There's the audio toolbox, which we saw here, which does some of this, but it actually compiles MATLAB code into C++ before it generates the plugin. So C++ is a lower level language, definitely, than MATLAB, which means you get more control over what is happening behind the scenes, over memory allocation and stuff, and thus higher performance code than higher level languages. And with low level, high level, we mean low, high level of abstraction. So the lower level, the closer you are to the processor. Also, JUCE is extensively used in industry. So for example, if you know Maximus P, that is created using JUCE. And there's all these companies. This is just a very tiny part of the long list of companies that use JUCE in their products. So when you go out there in industry, it's good to know C++ and JUCE for that reason. Great. So for the rest of this workshop, we will first build a noise generator from scratch. So I hope that all of you manage to download the producer and make a plugin from scratch and build it. We will append that code to build a noise generator, first of all. Then after that, I will put some code. I will give you a link where you can download a project. And then we can add some frequency control to a sine wave generator. So you will be making a slider, making it control the frequency in real time. Then from this application that you made, we can generate a VST quite easily. And then finally, we are going to go towards building a Flanger plugin. And it depends on your level of experience with C++, how far you get with this, but all the steps will be on the slides, which you'll also put on the conference website afterwards. So you can look at this at your own time. But let's see how far we get. There's a lot of ground to cover. All right, so let's take a look at the producer and what that is. So it's essentially an application also made in JUCE, by the way. And it creates C++ boilerplate code. So it creates templates to get you easily started. Actually, I learned C++ using JUCE because it was very easy to get quick results and to experiment very, very quickly. So there's this entire list of templates which you can use. And today we will be working with the plugin or basic template. So maybe to just get started, if everyone opens the producer and selects plugin basic. So just get going with that. In the meantime, do we have any questions in the chat? No. Great. Cool, so once you've done that, give your project a name. I don't think it matters whether you call it noise_generator or not, but that is what I called it. So it might be good to follow along with that. And you can do that in this top new project, that project name field. And once you've done that, you can click on Create Project in the bottom right to create your project named Noise Generator. Okay? If at any time I go too fast, just raise your hand or interrupt me. Do it. Cool. Then once you're here, we need to have one more thing before we continue, which is to click on this settings icon that you see on the top left. And once you've done that, click on this add using namespace JUCE to juiceheader.h. Make sure that that's enabled. Essentially what this does is, assuming that you are in the JUCE namespace in your C++ code, so you don't have to save to every JUCE variable or type name, JUCE : type name. It will make programming easier in the end. And although it says that it's enabled by default, I don't think it is. So please enable that before we continue. Yeah, and then once you click on the File Explorer, which is this on the top left here, you can see that the producer created 4 files: the plugin processor.cpp and .h, and the plugin editor.cpp and .h. Okay, so these files basically describe a class plugin processor, and these 2 files describe a class plugin editor. And they are separated into 2 files, generally for having a better overview of what your kind of structure of your file is and what the implementation is. So maybe just to go a step back and go into what the C++ file structure is. The .h file is a header file. We call that a header file. And the CPP files are source files. And basically, the header file describes the interface, or kind of the skeleton of your class. And the CPP describes how this class implements stuff, or the implementation of your program. So maybe, actually, if I quickly follow your steps as well. So if I create a new project and click on Plugin Basic, say Noise Generator. Yep. Let me put that in NordicSMC. Yeah. Can you just tell me what you mean?
Zoom in.
Zoom in, right, thank you. Cool. So now we have the noise generator, and I click on settings. I say enabled to this guy. And then here, File Explorer. Yeah. So we were talking about the H files, right? So for example, if we click on plugin processor.h, we can see that this is a file that has many functions. So we have here a class, which is an audio processor, and it has all these functions that do different things, right? So this is a very nice, in 59 lines, you can already see what your class is. And then in the .cpp file, we define what every single function does. So there's a lot of stuff here. But once your code gets very large, you want this to be separated in a CPP and a .h file to have this overview. Okay, what does this do? What function do I need to look for if I want to change this? Yeah, so that is essentially what that is. And in the editor, it's the same. You have a very small skeleton of your class, and here the implementation has more code, though less than the processor. Okay? Okay. Yeah, so in the .h file, you declare your variables and your functions, and in your CPP file, you define these variables and define what the functions do, essentially. And the H file gets included and the CPP gets compiled. So this is the difference between these files. So all in all, the H describes what your class does and CPP how. Okay? So of these 4 files, the plugin processor handles the audio part of your application. So it runs at audio rate, essentially. And the plugin editor handles the graphics, or the GUI side of things. So whatever audio processing you need to do, you do it in the processor, and whatever sliders you need to put and whatever control you need to give, animations you need to animate, you do that in the editor. Okay? So yeah, the editor handles the GUI. So it contains 2 functions which are quite important. One of them is the paint function that takes in a graphics variable from the JUCE backend. So you don't have to know where that variable comes from. You just know that you can work with it and use it to draw things onto the screen. Okay? And then we have the resized function. So yeah, so the paint function determines the appearance of the editor. So you can draw rectangles, lines, whatever. You can basically paint the background of your plugin. And the resized function is where you generally place your child components. So you place sliders, knobs, other components. You place them in the plugin using the resized function, or in the resized function. All right, so maybe for our first hands-on exercise, let's play around with the appearance of the plugin. So you can go to your plugin editor.cpp file and find the implementation of the paint function, and you can see different ways that the editor paints to the screen. So you can see a fill all function and a text which is placed somewhere and what the text is. So maybe play around with the values of those. And then maybe also play around with these functions. So you can, this is the way you would draw a rectangle or fill a rectangle with these parameters. So maybe just to get you started a bit and see what this all means and how your, like where the 0 coordinate is, for example, in your GUI. Just play around with this for, I would say, 5 to 10 minutes, and then we continue. Yeah.
Is that inside the voice noise generator, or this is the editor paints?
Yeah, exactly. So it's this huge thing. I can maybe also show you this if I build this in Xcode. Yeah. So maybe that long function definition might be a bit confusing, and I maybe will quickly show you what that means. So also, by the way, we all know how to get to these files in your IDE. So in Xcode, you go into this, the left panel here, and then you can see noise generator, source, and then here are these 4 files, all right? Couldn't have opened because you do not have the permission. That's very nice. Anyway, then we'll do it from the producer. Yeah. Okay, so we have our editor here. Can I do this? No. Cool. Yeah, so the editor here has these 2 paint and resized functions, and they're kind of obscured by this entire noise generator audio processor editor thing. And what this is saying, I'm going to implement the paint function of this class, and this class is defined in your H file. So the H, this is how you connect the H file and the CPP. So in the H file, this is our class name, and this is the paint function in that class name, or in that class. So in order to call this specific paint function, because you might have more components that have a paint function, so you need to specify, okay, I'm going to now implement the paint function of this class, and now we can play around with all of these guys. Okay? And here you can also find the resized function, which we will use later. Yeah, of course, of course. Good point. There we go. Ooh, yeah, and maybe Prithvi, you can, and if you haven't done that already, you can put this link in the chat, so that there's way more paint functions as well to play around with. Huh. Okay, 1 sec. Cool. So if you haven't changed anything, this is what you should get. Just a hello world application. Yeah. Stroke is the line thickness. Yeah. In pixels, I'm pretty sure. And, ooh, yeah, I forgot to tell, the way that I wrote here, the asterisks, is because it's optional. So I think there's a default value for stroke that you don't have to specify, except for I think you do. This was from an old version of JUCE. Maybe you can try to say draw rect without the stroke, and if you get an error, then you do need to specify it. Actually, try that. No, works, actually. Yeah. So here now I drew a rectangle of 10 by 10 pixels, and it's in the bottom, or in the top left corner. So you can also see that the top left corner is the 0, 0 coordinate. To know how many pixels you have in total, that is up here. So in the constructor of this guy, we won't touch upon this until later, but for those of you who want to know, we set our size of our application to be 400 by 300 pixels. So if we want to have this rectangle in the bottom right corner, we would say 390, 200, no, 190, 1010. So we start the top left part of our rectangle, or square in this case. This is not right. Anyway, might have something to do with the resolution. There we go, of course. Math in the morning. Yeah, thanks, Michael. Does this all make sense? Does anyone run into issues yet? Cool. Oh, wait. Yeah, so these guys are basically how the text is justified. So if you give it a width and a height that is way larger than the text, then you can tell it to be top, bottom, center, whatever. Yeah.
I'm able to get out, like
The what?
the hello world, or at least just the layout of it, the commands. Is that due to the path?
Are you? Yeah. Did you go to product? Yeah.
Silvin?
Yeah.
Hey, Oslo Hub is asking if you can please show the build process once again.
For the Visual Studio.
Yeah.
Yeah. I will try and do that. Let's see if this works. Can't handle my desktop. Yeah.
What should do is when it's worked the script to explode and try to run it as build failed.
Okay. Well, what are the errors that you get? You can see it in the left panel, I think. Mm.
Yeah.
All right, I'm gonna try this differently. For the UIO people who have problems building in Visual Studio, I'm gonna try and do it in Mac, and I think the steps should be the same. Are you guys running Visual Studio 2017 or 2019? Because if you are running, or if you are trying to export to 2019, and then it starts up in 2017, then you will get errors, actually. If you are running 2017, you will need to add in your exporters, you will need to add a new configuration. Oh, no, that's not right. You need to add here. If you click just next to the things that you already have, you need to add Visual Studio 2017. OK, you are running 2019. Cool. So that should be fine. Yeah, so then this shouldn't be grayed out, because I'm on Mac, it's grayed out. Then you save and open, and then once you're there, you just click on Build, and that should work. Are all of you getting the same errors, or we'll try one more time. Yeah. This is why I don't use Windows. All right, that's not going to work. Yeah, maybe we should continue with the workshop, and in the next hands-on, I will help you in the UIO hub. Cool. All right, you will have more time soon also to play around with this more, but I think we should continue to the audio. So if we look at the plugin processor, that is the one that handles audio. And it has a few important functions. It has a lot of functions, as you can see, but the few ones that we will be working with are, first of all, the process block, which gets called once every buffer. So basically, if we have, for example, a sample rate of 44,100 and a buffer size of 256, then we get around 172 times a second that this function will be called from the JUCE backend. So for those of you unfamiliar with a buffer and who have done only sample-by-sample processing, in real-time audio processing, we take a chunk of input audio and then process that and give it to the output, because that is I guess if you do it sample by sample, it will create a lot of overhead in the real-time aspect of things. So yeah, this gets called every buffer. And then we have the prepare to play, which gets called at the start of the application. And this is where you generally want to obtain your sample rate from your DAW or your plugin host and initialize your variables. So for those of you who have experience with the audio toolbox of MATLAB, the process block is essentially the process function. And the prepare to play could be seen as, I guess, the reset function or the constructor where you initialize stuff. Okay? Okay, so let's create some sound then. So yeah, we called our file noise generator, which was kind of a spoiler for what we will be doing now. And in order to create noise, we need random numbers. So JUCE has this very nice class called random to create random numbers. So we can define a variable called R, which is of type random, or it's an instance of the random class. And then in order to get a random number, we call its next float function. So we define random r, say r.nextFloat, and it creates a floating point number between 0 and 1, 0 included, 1 not included. So maybe try to, in the process block function somewhere, create one floating point number per buffer and print this to the debug console or your output console. And this is also a nice practice to find where that is. And you can print using this dbg, debug macro, and then you put your random value between its brackets, and then you can print it to your console. Okay? So maybe try that. And then in the meantime, I'll try and help the UIO people. Maybe for those of you who are done with this, try and change this value to be between -1 and 1, because this is what we will soon send to our speakers. And the speakers take values between -1 and 1. If it's less than -1 or larger than 1, you will get clipping or you break your speakers. Yeah.
Where is the can't find the process block?
Okay, the process block is right here. Let me see. Open recent. Yeah. So if you are in your plugin processor.cpp, then there should be a process block function right there. And it is preceded by the name of the class, again, that is defined in the H file. So I think it's line 132 around there. That is where, yeah. And then I guess somewhere here is where you can insert your random code.
Can you turn the slide?
Yeah, of course, of course. There you go.
There's a question about finding the files in Visual Studio.
Yeah.
I was wondering, maybe could you like show the Solution Explorer?
Yeah. If yeah, I wish my Windows would work. I think sharing screen and trying to run a virtual machine is a bit too much for it. But maybe I can. Let me see. There we go. Okay, so for those of you who are still having troubles building for Visual Studio, I have my noise generator here, and then I added the module for me, Visual Studio 2019, because I was running on Mac. Then I build in Visual Studio. And then it opens 2019. So it's important that the exporter that you see in your producer matches the one that it opens, because otherwise it will give errors.
Just every time.
Okay. So one of you asked for the Solution Explorer, and that is right here on this side. Then to find your code, you'll need to go in Shared Code, Noise Generator, Source. This might have been a hard find if you're not experienced with Visual Studio. But then here you can find all your files, and once you click on one of them, you can see your code. And then around line, what is it? Nope. Yeah, 132. That is where your process block lives, or is implemented at least. If you then build, then it should create your standalone plugin straight away. After a while. And here it is, the hello world, with actually the little square still from our paint function. Yeah, so maybe just to clarify, this random variable, so this R here, is not a number itself. It's rather a random number generator. And it can generate different numbers by calling its different functions. So you can say r.nextFloat, and this will be a number. So if I say dbg rnext float, then I can maybe also immediately show you where this the output window is for so where you can find the values that it prints after it's building. Okay, yeah, okay, so it automatically shows it here for me. But if it shows the call stack instead, for example, then here there's a tab called Output in the bottom right, and then there's where all these numbers are appearing. And you can see that it's generating random numbers between 0 and 1, right? Yeah, so any other questions about Visual Studio? Then it's working now. All right, so how many of you here have managed to create a random value between -1 and 1 and print it to the output and found the output? Cool. So at least some of you. Is there still people that have not been able to do this? Okay.
Get some errors.
Errors, okay.
I don't know how to, like, what class it is, how to handle it. It's just
All right, I think we should continue. If you still are having issues with printing your value, then you can do that in the next break and ask me in the Q&A if you have issues. But let's move on. Okay, so now we are printing a value every buffer. So in order to access every individual sample within that buffer, we need a for loop. And so let's continue and try and make a for loop within our channel loop, actually. So you can see a loop for every channel. you can make a for loop within that channel and generate a buffer size. So like however big your buffer is, that amount of random floating point numbers per channel, it should actually say. So you will generate 2 channels of random floating point numbers. So try and do that, and then I'll answer your question.
But don't create a new for loop, but just use the...
No, you create a for loop within the channel loop. So let me see. If I go to here, let me close this.
Where? Here. Because you just printing.
Okay, so instead of doing it outside of our channel loop, here we have to create another for loop, or create a for loop, looping over the buffer size essentially. And to obtain this buffer size, you use this function. Sorry. So you use the buffer.getNum samples, and then you can obtain how many samples are in your buffer, and then you know how to loop over. And then maybe when you've done that, you can start writing data to your speakers. But please put your volume low, and also make sure that your values are between -1 and 1. But you'll have maximum amplitude noise if you do this straight away, so watch out for your speaker level. Maybe this is also the point where you need to put in your headphones. Yeah. And of course, this I value here is given that you are looping over I. So our first for loop was int channel equals 0. If your second for loop starts with int I equals 0, then this is the value or the variable name that you use. If you say for int x equals 0 until your length of your buffer, then channel data would be indexed by X.
Probably float, but you don't care. It's already, no, you don't. It already defines itself. When I have it, how it work? Yeah, I mean, when I see Sean, data, it's found it. Well, float channel data, I don't know, some find out.
Who is getting noise already? Anyone online? Can raise your hand, I guess.
Silvin, there's
Yeah.
a question about debugging in Xcode and displaying the debug output.
Yeah.
It's in the chat, so you won't see it in the queue.
Okay. Okay. Yeah, let me quickly show also in Xcode where your output window is. So you should have this panel below here. And if I build here, then this should appear in this bottom right pane. Bottom right panel. Yeah.
Yeah, you have some. No, but it should be declared. Oh, but yeah. No, auto, you cannot do it. Because auto, when you do auto, you don't do equals something. Because then this variable will be overtime. No, I think that I'm doing those.
Yeah, so if for some reason in Xcode you're not getting any output or your thing builds but doesn't show, be sure to go to Product, Scheme, and then make sure that you have standalone plugins selected. If not, I think by default it selects VST, then it will only generate your VST, but it won't allow you to debug, or it won't give you the standalone plugin window. So that should help if you're not getting your application to appear on the screen after you build.
Oh, exactly. Wait. Oh,
Anyone getting noise yet?
no, why?
All right.
Show these directions.
Yeah. Yeah. Okay, so maybe I will make the for loop for you, so you can follow along with that. So the for loop will have the same structure as this guy, but then instead of, so maybe for those of you unfamiliar with C++, making a for loop requires you to define a variable that only lives in the for loop, an integer which you iterate over, and in this for loop it's a channel. And if we create a new for loop, so we say for int, in my case I usually do I equals 0, so 0 is this place where we start, and here it will, yeah.
Do we create a for loop inside the other for loop?
Yeah, you create a for loop within the channel for loop. Yeah, exactly. So yeah, you create the for loop within there, and then you determine when this for loop should stop. So you say, okay, it goes from 0 until buffer dot get num samples. So this is where it should iterate between. So between 0 included until, or between 0 and get the number of samples in your buffer. And this is excluded, this number, because you are smaller than this. And then we can say ++i or I++ to iterate after every loop. And this is our for loop. Yeah.
Any advantage to using auto and letting the compiler work out what time it should be?
I think if it wasn't auto, it would be something like const float. When you have types that are kind of long, you usually use auto, and the reason that I use auto here is because the producer gives it to me.
Well, yeah.
Yeah. But the auto keyword is, I think, well, relatively new in the C++ language. But if your variable or if your allocation can infer from the right-hand side of your line what the type is at all times, then you can use auto. And I think this should also work, but because it is a const float pointer, but usually if you use auto, you add the pointer to clarify for yourself, okay, this is actually a pointer. Yeah, exactly. Ooh, yes, this reminds me, if you are printing while you are playing audio, printing costs a lot of effort for you, or it will cause audio dropouts. So if you generate audio, remove the debug or this DBG thing from your code. Yeah. Yeah.
Could you please share the slides to the Discord?
Yeah, I will do so in the break. We're getting noise.
So channel data where?
Yeah.
You're in your channel inside. It's not happening here as you're then taking
I generate some variable. I initialize some variable that gets the random value from this run. And I
I think that I will just write, guys, could we, I think the microphones pick up a lot of stuff. I will just write the line of code that is still missing from this, which would be channel data I equals our random number generator. Next float. And then in order to get from a value between 0 and 1 to a value between -1 and 1, we multiply this by 2 and subtract 1. And this should create noise. I don't think I want to play this because of sharing audio and how loud it will be, but maybe I can do it if I apply a gain like this. Not sure if you will hear it, but let's try. Also, I don't think my voice will be going through the webinar. You hear something? Okay. It's going through my speakers, so I should select this guy. So I also don't think my voice will go through the webinar once I'm sharing sound as well. So remind me not to talk when I'm sharing sound. Noise. Okay. Cool. All right, so maybe I will quickly go through the structure of what we now have in the process block. So we have a structure that for all channels, could you guys please use headphones? For all channels, we get the right pointer of that channel, and then for all samples in the buffer, which we know how big our buffer is because of this buffer.getNumSamples, we write a value to the sample index. So using this structure, we can insert the code where we have for every channel, we get the right pointer. For every sample in the buffer, we write this code to our channel data. I hope that makes sense. Okay? All right, maybe the last thing before we take a short break, try and create a variable called gain. And you can make this private. So private variables are basically for object-oriented programming. You can create private variables that are only visible to the class. So it's kind of a programming safety feature. So we can add a gain variable. Let's make it float or double, doesn't really matter, and give it a value between 0 and 1. And then just like I did before with my code, we can apply a gain to the entire signal before we send it to channel data. And then change the value, rebuild the program, and see whether it changes the volume. All right, maybe we can also insert a short break here, 7 minutes, so we are back at 10:15. We can grab a coffee, grab some air, catch up. I'll upload the slides to the conference webpage. Yeah, so let's be back at 10:15. All right, it's 1:15, so let's continue. Does anyone have any questions in the meantime? Also, please keep on putting on the Q&A online. I have one question here, if I can show the Xcode project, but I will take that in a minute. Cool. So, yeah, did you guys manage to do this? Apply the gain to the noise and see that the value changes? Cool, very nice. So, wouldn't it now be nice, in a minute, wouldn't it be nice to control this gain in real time? Yes, it would, definitely. So maybe go to this project. I think Prithvi will put the link up in the chat so everyone can see it and download it, because for the rest of the workshop we will take this as a basis. And I'll wait a minute for people to download it. Wait, so the question was, why not use the producer itself and use a separate IDE? I think JUCE came with their own kind of IDE type of thing, which is the producer for this live editing and live coding. So being able to change the colors and sliders and whatever on the fly while seeing the GUI on the side. But I think that they also recommend to use your own IDE, what you are comfortable with. Yeah. I tried to use the producer once at the beginning, but then I quickly moved to the other ones. I'm not so sure. We should ask them if there's any advantage of using their built-in code editor. Oh.
I think as the project grows in scope, it makes sense to use a more full-featured IDE.
Exactly. I think that JUCE is just for creating the files, and then whatever extensions you might have in Xcode or Visual Studio, you can use on that code. Yeah. Okay. I'm gonna assume that everyone found the project and downloaded it. Did you also manage to build it? So just with open the juicer file and click on build, save and open in IDE, and try and build it. And what you should get is a sine wave. So let me also try and do that. So again, I don't think I should talk while this is sharing, but let's see if this works. Wonderful sine wave. Can anyone guess the frequency? Yes. Good. All right. So I changed a few things in this code compared to the one that we just saw. So I might want to just go over that with you guys. First of all, if you go up to line 94, you can see the prepare to play function, which, as mentioned before, is where we obtain the sample rate. So the sample rate gets passed in by the JUCE backend as an argument here. And then you can obtain this and save it to a member variable of this class called fs. So if I now go to the plugin processor.h, we can see that I have a private variable fs, which is the sample rate that I want the class to know and have also in the process block function. So maybe, again, for those of you unfamiliar with C++, this sample rate variable is only known here in this scope. So there are scopes in C++ between these curly brackets, and if you define variables in there or use variables in there, they're not going to outlive the scope. So you need to obtain this, you need a private member variable to save it so that you can also use it in other functions. So this fs is now known to the entire class. Okay. Then, so here we have our for loop, which we saw before as well. And now I added an input variable, which we will use later. Then the channel data is, let me maybe make this a bit bigger. Yeah. So the channel data I renamed to output, just to have a better understanding of what it is. I have an extra variable here called non-limited output, and I implemented a limiter for you guys. So it's really important in real-time audio processing to have a limiter to make sure that you don't have get values to send to your speakers below -1 and +1. So we're doing the audio processing here, sending it to non-limited output, and then we limit it before we send it to our output buffer. Okay. The limit function you can find all the way down, which is simply we get in a value, we have a minimum and a maximum value, and then when the value is smaller than the minimum value, we return the minimum. When it's larger than the maximum, we return the maximum, and otherwise we return the value. Okay, so this is just to protect your speakers, your ears, etc. Cool. So now we are back in the in the process block. Yeah. So here's where we create a sine wave. So I have here a gain variable. I have a sine wave, and the sine wave is generated using this. I'm pretty sure, well, you guys here are familiar with how to create a sine wave also in MATLAB. So you have 2 times pi times a certain frequency. Then here's your sample index. So this is a sample number. It's an integer. And then in order to get it to seconds, we need to divide by the sample rate. So this n variable, we increment every iteration, every time step we increment that to get the sine wave in the end. Yeah.
Couldn't we use I instead of 10?
We get a question whether we can use I. I is linked to the buffer and the buffer size. So every buffer, it will go back to 0. So it's kind of like setting t to 0 every single buffer. So this guy should continue to increment to get the smooth sine wave over different buffer sizes. But good question. Yeah, so this n is also here a private member variable used as a sample index for the sinusoid. Okay. Then also the gain is a private member variable. You also made that for the noise plugin just now. And this gain we can actually control. And for you guys to see the control, we need to take a look at the editor. Okay. So let's go to the editor.h file. So this is the editor class. And the first thing that you want to do when you want to implement slider control is to make this editor inherit from the slider listener class. This is not as important because this is already done for you. It's just important to know what has been changed from the original JUCE template. So we inherit from the slider listener class, and if we do that, we need to implement, or we need to declare this slider value changed function. So if our class is a slider listener, it needs to override this function called slider value changed. Otherwise, it doesn't make sense for it to be a slider listener if it doesn't have this function. For those of you who know C++, this is a pure virtual function of this class, meaning that you have to implement it if you inherit from this class. Doesn't matter, this is done for you. When doing this, first let's do this. In our private member variables, we now have a slider object. So we have our gain slider, which if you build the project, you can see a slider in the middle. That is this object, okay? So also you can see here that I added some comments with certain step numbers, and these correspond to a document that you also can find in the folder that you downloaded. It's in instructions/parameters.pdf. And then there's different sections with different types of steps. And one of them is called adding parameter control. And this is step 1, essentially. Okay. Cool. So that is all that we changed in the editor.h file. So let's move to editor.cpp. So this is, again, the implementation of things. So here we actually change a lot. So in the constructor of the editor class, so the constructor is something that gets called as the class gets created. So before anything else happens, the constructor is called. And here's where you want to set up your slider. So we set up our slider. We have a lot of different things that we can change in our slider. We can change the layout. We can change the slider to be a rotary knob. We can change it to be a vertical, special colors. We can change everything. But the most important for our purposes is the set range and set value functions of the slider. So we have our gain slider, the object, and then we call the set range function to be minimum 0, maximum 1, and a step size of 0.01. So this is basically setting up how our slider behaves or what values it can output. Okay. Then we initialize it with a value of 0.5, and this matches our gain in our processor.h, but it doesn't have to. As long as this value is between the minimum and maximum of your slider. That's all you need to know. Then the next step is to add a listener to the slider. So if the slider is going to move, it needs to tell something, right? It needs to tell, in this case, the editor, that it has moved and its value. So we add this object, and this is essentially saying, I'm adding this object, the editor, like this class. I'm going to add that to the list of listeners of this slider. If it doesn't make sense, don't worry. You have some time to look through the code and experiment yourself. And finally, in the constructor, we call this add and make visible function with the slider as an argument. So this function makes sure that the application, the JUCE application, knows about the slider and makes it visible. If you don't call this function, you have an invisible slider which is not added to the application. It will not work. Okay? This one you always forget. So that is why it's also important. Okay? Then we move down to the resized function. So remember that the paint function is to kind of paint the background of your plugin. You don't work with components in there. So the resized function is where you place different sliders and knobs in your user interface. So there's some text which you can read in a minute. But all that we're doing here is to give the slider bounds. So we can say to the slider, this is where you are in the GUI. And what I called here is a get local bounds function. So what this returns is these values. So x equals 0, y equals 0. So from the top left corner of our user interface, and then its width is the width of the application, and its height is the height of the application. So basically, what do I live in? What position and what size is it? Alternatively, you can set this to be 0, 0, get width, get height. So you can also change the location of your slider manually. Cool. So then we have the implementation of our slider value changed function. So here, the slider functionality setup is simply implementing this function. It's done for you. You don't have to worry about that. And then we can, from this function, this function gets called whenever the slider is changed. So you know, okay, if the slider is changed, this function is called. So from this function, we can send information to the processor. We can send, okay, the slider value is now 0.7. I want to send that to the processor, change its gain, and then in the audio thread, it will have changed the value of the gain. Okay, so it's kind of like this thinking process of what happens between the slider and the sound. How do I get there? So again, when the slider is changed, this function is called. And here we have an if statement. Even though we only have one slider in our application, it's always good practice to have an if statement to check whether the slider that gets into this function, or that kind of calls this function, is actually the slider that you're looking for. So if this slider is the gain slider, because the slider is a pointer, we need to take the address of our gain slider. C++ stuff, just copy paste in a minute. Then we set the gain of the audio processor to be the value of the gain slider. Okay? And this set gain is a custom function that we will see in a minute. But essentially, we take the value of the gain slider and we send that to the audio processor. And this audio processor is a private member variable. I'm now going to plugin editor.h. There's a private member variable from the editor. So the editor knows about the processor. It can call its functions because it knows about it through here. And I'm going back to the CPP. So we set the gain to be the slider value. So if we now go into the plugin processor.h and try and figure out what this set gain function actually is, we can see that this is what I added on top of the limiter, by the way. But here we have set gain. Then we have a gain to set. So the name of this variable doesn't matter as long as you use it in its function definition. This is where the slider value will go in. And then we set our private member variable gain, which is living here. We set that to be whatever comes into this function, which is our slider value. So it's kind of complicated, but this is the way it works. And in a minute, you will go through these steps and add an extra slider so you can kind of internalize what is actually happening. But take your time to follow all these steps, and after doing it 1,000 times, it will make sense. Yeah, I think that's it for the code changes that I made. So now we have a gain, right, that we can control in real time. So let's now add frequency control as well. So we have now our output is calculated by a gain times a sinusoid, which is takes as an argument 2 pi times the frequency times the sample index over the sample rate. Okay, we know this formula. So now, before we add an extra slider, maybe follow the steps in this parameters.pdf to just add a parameter to the audio processor. So it's similar to what we did for the gain in the noise, which wasn't controlled or anything. Just add a frequency parameter and try to replace the 440 that you saw in the process block by your private frequency variable. Go ahead. And then, of course, once you've done that, change the value, rebuild, and try and listen whether your frequency has changed indeed. The PDF. It should be in the folder that you downloaded. And it's in instructions, in the folder. And then there's 3 files there, and one of them is called parameters. One of them is called NordicSMC something something. That is the file that you saw before the start of the conference. And there's one other file that we'll see soon. How about now? Is it better? Rubbing sound. What's this guy?
Now it's not working. Okay, hold on.
Right, so for those of you who are done with this, you can just follow the steps. This is the hard one. Follow the steps in the document and in the code to add frequency control. So we're now actually going to add a slider on top of the gain slider that now controls this frequency variable.
Is there a way to...
Yeah, so we got a question about how to set the gain smoothly. So you have this discontinuity because the audio rate and the control rate are not the same rate. So what you could try and do is save the previous value of the slider somehow and average that out, or make some sort of kind of a low pass using 99% of the previous value and 1% of the new value. Some kind of linear interpolation like that. Then you can smooth that out. We will not touch upon it in the workshop, but that is a nice addition if you want to implement that.
So we don't have to leave this. Let's go on the other steps.
Yeah.
Coordinates.
We got a question about whether the get local bounds only makes sense when you have one component. In a way, yes. I can maybe in a minute show you a smart way to go about localizing components by kind of dividing it into rectangles and that kind of stuff. So you can create a rectangle type variable that gets the local bounds, and then from them you can use functions such as remove from top, get height times a half or something, and then the next one get remove from top, so you can kind of build it like that.
Yeah.
They would get the local bounds to get the full area, and then kind of chop it up into smaller sections,
Makes sense, yeah.
at the same time giving bounds to your subcomponent.
Yeah, rather than having to just sort of.
Yeah, doing it manually. Yeah.
Got it.
You do have kind of automatic. You can use the get height and get width to have that be adapting to if you change the size of your window. So you don't have to fill in 400 and 300 by hand. You can use the get height and get width for that. But yeah, there are smarter ways. That is. So for those of you who are quick and have already implemented it, the slides are on the Discord channel. I'm not sure if you guys know about that, but I'll send it to you. Then you can just go ahead and fast forward. But I guess in 2 minutes we'll continue with the slides. But just so you know that there's more material available. So we got a few questions about the bounds of the sliders here. So right now our gain slider is placed in the GUI as a like in the total area. Guys, could I have 1 second? It's placed in the GUI as the total area. So we have to give the gain slider different bounds so that it doesn't overlap with your frequency slider. So probably maybe the top half, try and figure out how to make the top half the gain slider and the bottom half of your GUI the frequency slider. You can, instead of the get local bounds, you can, as said in the comment above it, you can specify X, Y location and width and height separately. So that is what you need to use for the gain slider and then also the frequency slider. All right, I think we should continue. It doesn't matter if you're not done yet. You are given time to finish it afterwards. So for those of you who do have the frequency slider, the changes in frequency are not smooth. So you get all these crackling sounds when you're changing the frequency. And the reason that this happens is we have for example, if we have a sine wave with a frequency of 1 Hertz, and then at a quarter second, for example, we want to change it to a frequency of 1.5 Hertz. Then at the moment that you're changing it, it will kind of drop, it will kind of click there. And here the phase difference is not too much, but if you are further on in time in your application, the phase difference might be a lot. So it might jump straight between these two sine waves. So in order to fix this, we can include this code. So instead of going from a full-on 2 pi times whatever frequency times a certain time, which always depends on where t equals 0 is, we can work with the phase directly. So you guys here in class, you've learned how to, or that when you go with a point around the unit circle, you can create sine waves. And the same we can use here. So say we have we try to generate a sinusoid using this technique. We can start at this phase. And here in this code, this is the current phase of our sinusoid, essentially. Then we can increment this phase, every sample, based on our frequency. So the larger the frequency, guys, the larger the frequency, the larger the phase increment. So so this will be one iteration, and then in the next iteration, that will be our current phase. Increment it again with the same one, etc., etc. So if we continue this, and every one of these points will be a sample in our sinusoid. If we continue this, we have a single frequency. If we then want to increase the frequency, that means that we increase our phase increment. So this is our theta 2. But now you can see that it includes our previous phase. It includes where we are in the sinusoid generation. So if we want to create a sinusoid from this, we can say, okay, we have this sample, and this sample. And then if we now want to increase the frequency, instead of continuing this sinusoid like that, we actually increase the frequency like that. So you can see here in the top that instead of having this drop to a new frequency and not knowing what the phase is, now including the phase will actually make this smooth transition between two different frequencies. All right? So for those of you who are there, you can implement the smooth frequency control using the following code. So this is just a copy-paste type thing. And then you need another private variable to keep track of the phase within the class. Yeah, so go ahead. All right, maybe can I get a show of hands of who has a working second slider, be it with this smooth frequency or not?
I have it. I might not have actually.
Cool. I hope all you guys online also are with us. Otherwise, don't hesitate to ask more questions. I see you there.
No, I could. It would be the end sound. Yeah. I have.
We're getting some questions about the slider bounce, and maybe I should just go and show you that in practice. Let me see, maybe if I just comment out the sound, so we don't. Yeah, so if I go to the editor.cpp, right now, if I build this guy, I should get a slider right in the middle, and it should, yeah. So this slider, even though it only looks as if it is in the middle, it basically goes over the entire width and height of our graphical user interface. So what I did here is get local bounds. It returns the size or the location and the size of the current window. But I can also say 0, 0, get width, which instead of get local bounds only returns the width of the application, and get height only returns the height of the application. So if I build this, this should give me the exact same thing. Okay? Which it does. All right, so now if we want to add another slider, then we need to locate this guy a little differently. So what we can do simply here is half the height that we give it. Still have the same position, so it will be in the top left, but now we expect this slider to be just in the top half of our GUI. And it is. All right. So now we have room for an extra slider. So if I go to my plugin editor.h, I say slider at or add a frequency slider. Then here I do all of this stuff. And then the range should of course be different, right? Because our frequency needs to go not from 0 to 1, but from maybe 20 to 2000 or something. And then we can also set its value to start at 440 Hertz. Okay? Then step 3, we add a listener to it, frequency slider, and then we add a make visible. So we're just doing the exact same steps as done for you with the gain slider, but now we're doing it with the frequency. Okay, so now we have everything we need to give it bounds. If we copy paste this, we expect our frequency slider to also be in the top half of our application. So what do we need to change in order to get it to the bottom half?
XY. The height.
Yeah. No, the height is fine. You said XY. Which one of the two?
The Y.
The Y. Yeah, exactly. So we need to change the Y value to move it down. So again, 0 is in the top left. So what should Y become in order for it to be in the bottom half? So that's 1 pixel.
Oh.
height.
What
if it was 0.5?
Yep. So half of the height. So we have at x0, half of the height, and then it's the width of the application wide, and it's half of the height high. So now this should result in 2 sliders. Cool. And you can also see that this is now 440, going to 20, going to 2000. So maybe I should just continue and get it to work with our sinusoid. The next step should be to actually go to the plugin processor and add a set frequency function. I noticed that I don't have a frequency variable yet, but we can also get that. Set frequency, freq to set, and then I'll call my private variable freq. And of course, I need to define it underneath the gain here in order for it to exist. I have it be 440 Hertz. Okay. Then, of course, like this is the steps for adding a parameter, which I'm now doing. So this is the second step to apply it to the signal. So here I change 440 to be freq. Okay. So this is still the old implementation of the sinusoid, by the way. So I'm not including the phase. Cool. So now the last thing we need, step 7, is to link our slider value to the frequency value. So I can say here that else if my slider is the address of my frequency slider, we call this new function, this new setter function that we created in the processor, dot set frequency to the frequency slider dot get value. Okay, I know this goes maybe a bit fast, but it's exactly the same as we do here, but done from frequency. So if I now do set my output, so I can't talk while it's playing, but we can listen to it. And I hope that it's not too loud for you guys. So watch your headphones. Decrease the gain a bit, but then so it does work, but we have these non-smooth transitions. If you just click, you will have, I guess, smoother transitions, or it will be less apparent. Right, you guys on the webinar may not have heard that, but we didn't have smooth transitions, but when you click on the slider, you don't really hear this clicking because you're changing the frequency. Super fast anyway. Did that make sense? Cool. Then I think we should maybe continue because we still have some ground to cover. So we've now only built a standalone application, so we haven't actually built a VST yet. But this is actually quite straightforward to do. You just need to know where to look in your IDE to generate the VST. So these are just some instructions for Mac and for Windows, respectively. And I can also go through that on the screen, but just try this first, where in Mac you already know this product to scheme, and then instead of the standalone plugin, you select the VST3 instead, and then you build it. And then the VST will appear in this path, which is in your root folder of the project, build, Mac OS X, etc., until you find this VST3. Okay. In Windows, you see in the Solution Explorer, you see 3 projects. One of them is shared code, one of them is standalone plugin, and one of them is this VST3. Simply right-click the VST3 and click on Build, and then it will generate it in the path. So in the meantime, I'll try and implement the phase type of sinusoid making. The rest of you, the slides are either on Moodle or on the Discord channel. Yeah. So we have a phase increment that is, let's see, 2 pi times the frequency over the sample rate. And so you can also see that with this, we don't need this time index anymore, because we're just generating it from our current phase and our previous phase, essentially. Then in our processor.h, we need to create a private variable, so phase, called cur phase, and we need to actually set that equal to 0. So it might be that if you don't set it to an initial value, that might cause some issues. Then your current phase gets incremented. So for those of you unfamiliar, this plus equals does the same thing as curve phase equals curve phase plus phase. Okay, so these two lines of code are essentially doing the same thing. And then we input that into our sinusoid, and then we should get smooth frequency. Unless I did something wrong. Nice. Cool. Did everyone manage to build their VST and also find it? But the build was successful, right? Yeah. Oh. Cool. Then for those of you who built it, you can also try and build the audio plugin host. And the audio plugin host is a very nice way for you to test your plugins without needing a DAW like Ableton or some other stuff. This comes with the JUCE package that you downloaded. I made some instructions which can also be found in instructions/audio plugin host, where you will need to build this guy. You will need to open the JUCE project, build it, and then you can find it somewhere in your folder structure. And then from there you can input your plugin and link it to the output, and then get the same result. And I think especially this is useful if you have an audio effect rather than an audio generator, because the generator you can already hear when you build it, the standalone plugin, but if you have an audio effect, you need some other input in order for it to work, or to create sound. It will work, but without an input you won't create sound. So yeah, find the instructions and try and build the host, and then you can try and host your VST plugin. And yeah. Maybe we can also have a very, very quick break before we have the final stretch. Maybe let's come back at, so again, 8 minutes, and then finish. All right, let's continue again. Remember to ask questions in the chat if there are any problems. Yeah, just try and play around with this plugin host thing. Maybe before we move on, it might be nice to show also how you can use audio input. So now we've only worked with audio output, but like output of a certain index, you can use input of a certain index to obtain your mic or audio input. So for those of you who want to do that, try and change the sinusoid to an external input, and then build the VST and try to import it into your plugin host. And then in your plugin host, you can also add a default instrument. I will go through that in a minute, but you can add a sine wave synth there, which you can control with your keyboard, and then you can send that through your plugin, and then you can, for example, change the sinusoid to be gain times the input to have a gain slider and see that it works to your sinusoid synth. So yeah, maybe I'll just quickly show at least an Xcode for now, how to build a plugin. So maybe some people had difficulties with that. So here I go to product, scheme, and then I go down to VST3. And then now that you can also see that it changed up here, it changed to VST3. And if I now play, then it will build my VST, and it will be in the builds folder. Okay, so it succeeded, and it won't build anything. If you want to change that, I know how to do that in Xcode. You can select Edit Scheme instead, and then in Edit Scheme, you can go to Executable. So now you can also see we're editing the VST3 scheme. Go to Executable and launch the app. Although the app then probably doesn't get updated, so you will have to change this to all. Anyway, let's just stick to this, and then it will build to the VST. Let's see where it is. So here I have my NordicSMC effect. Then in builds, Mac, build, debug, here's my VST3. Okay? So if I then go to my JUCE folder, so so this is for the audio plugin host. If I go to my JUCE folder, which should be somewhere here. Yeah. So this is my JUCE folder, and then in extras, there is the audio plugin host. So in order to build that, I need to open the JUCER file and save and open an IDE. And then once that happens, I need to build it. So here my host comes. I'm gonna build it, and then it should appear in my builds debug folder, and it will actually also run it automatically. I'm pretty sure. So maybe once it's built, we can immediately try and add our VST that we just generated to this plugin host. Okay, so this is the plugin host, very nice. Then if we go to options, which is here in the top, we can edit the list of available plugins. These instructions are in that document in the root folder of the thing that you downloaded from GitHub. There's something called audio plugin host.pdf or something. And there are these instructions to do this. So we can open the available list of plugins, click here on options, and then we can scan for new or updated VST3 plugins. And you can see that I already added my NordicSMC effect folder, in which I just generated my plugin. I added that to the folders to scan, but we can do that. You press the plus button and find your folder, so your NordicSMC effect, You select open, and then it's there again. So I'll just delete the first one, and then select scan. And then once it's done, you can close this, and then right-click, and then in your NordicSMC pane here, you should see your NordicSMC effect. If you click on that, you should have this plugin that you have here, and if we link it to the output, we should get some sound. If we then double-click on this guy, you can see your GUI right here, albeit a bit different color, I guess. But so here we can change the gain and the frequency as well. So we can select, say here, left and right. So if you are looking at the slides, then you can also change the sinusoid to be the input, and then you can click and drag the input. So this is your microphone input, and then you can send it through this guy to go to the output. Alternatively, you can add a synthesizer, for example, Sine Wave Syn, link it to the MIDI input, and this guy you can now control with your keyboard. So I can do that. But you can also send it through your plugin. Right now this won't do anything because we're not taking the input in our code. But if we would change that, we can potentially take this to the output and then change the gain, not the frequency anymore, but just the gain of whatever comes in. If we say gain times the input, then that is what goes through. If you want to, I can quickly show you how to do that in the code. So here, instead of having the gain times our sinusoid, maybe comment this out. You can say non-limited output equals gain times input I. Okay? That's the only thing we change. And then recalling that we're now in our VST3 scheme, we build. So now only our plugin will be building, and it won't open anything, which is also good because otherwise we might get microphone feedback and so on. If we then open the plugin host again, so now rather than doing it straight from building it, we can also find it in the audio plugin host, in your JUCE folder, extras, audio plugin host, builds. And then in builds you have, for me it's Mac OS X build debug audio plugin host.app. I think for Visual Studio it's slightly different, but if you build it there, then you find it somewhere in your builds folder, and then you can also open it from there. So here it should have updated, but just to check edit list, I just want to delete it here. Can I do that? Yeah. And then do the same process, scan again. It appears. I add it to my plugin host, and now there shouldn't be any sine wave coming because we're just using the input. So that's good. We add our sinusoid generator, link that to our effect and to the MIDI, and then we pass the input through to the audio output, and we can change the gain here. So we can say gain is 1, or gain is 0. You don't hear anything. Okay? Yeah?
Is the input a variable, like a float or double, that you introduce in your script, in your code?
Yeah, so the input is here. So we get the read pointer of our buffer. And so that is kind of, we get one buffer in, we can take its input and we can fill it with output and then send it out to the DAW or whatever. So that is essentially what it does. Cool. So maybe for the last part, because we're running out of time, we have 24 more minutes. I can just quickly go through what I still have left, and then you can use whatever time you want on this last part, where we are going to create an audio effect, which is the flanger, and that requires a bit more stuff that we won't be able to cover, but the steps are in the slides, and I will go through them, and then for the really fast ones, you can do it in 23 minutes, and the others, they can do it at some other time. So the flanger is very interesting because it has this difference equation. So here, for those of you unfamiliar, y here is our output and x is our input at a certain sample n. So here we have our input straight, and added to which is our input delayed by a certain integer number, which is time varying. So this is the block diagram. We have our input, and it goes to the output straight, but also through a buffer, or a delay line, as you would call it. So it's important to know that this buffer is different than our buffer that we get into a real-time application. This buffer can be any size. And then the code. In code, this would look something like output of a certain index is our input of a certain index plus our delay line of some other index, which we need to figure out what is. So our delay line, we can make that a private variable of the processor. And we, in order to make a buffer, we use this type called a vector. And here what you see is like the std is the standard C++ library. From that library, we take the vector class, and we specify that it's a vector of floats. So it can also be ints, it can be booleans, it can be whatever. But for our purposes, because we're working with audio samples, we're using float. This one you need to then initialize in prepare to play. So we need to resize it to have we need to specify a maximum number that we want to delay our signal. So say 1,000 samples or something. So we resize this vector in prepare to play to be the maximum number of samples we want to look back. And then the best way to implement this is to use a circular buffer. And I know that we talked about that with you guys, but I quickly want to go through what the difference is between a regular buffer and a circular buffer. So I suppose a regular buffer, as you would call it, would take an input at its first index and kind of move all of the current states of the buffer to the right-hand side in this case, and then pop out an output. And this is how you would, this would happen every single iteration, every single sample. So in this case, it would take about 8-9 samples for our input to reach the output. But the exact same behavior can be obtained by using a circular buffer, where instead of doing it like that, moving all of our data, which is quite costly, especially if your buffer is very long, we can have a write location and a read location and move these around. So we write values to our buffer, and the read location is on the opposite side to have the maximum delay, and then these will move every single sample. So you can see now this read location, once you wrap around to the other side, which will be the big challenge in a flanger to kind of use this linear looking buffer as a circular buffer. This guy will reach the first write location after a buffer's length of samples. So yeah, this is how the circular buffer should work. And then we can modulate this read location to get our flanger. And note that this read location should not be able to surpass the write location on the opposite side, because then you will get clicks like this. This is a nice sine wave, and this is the nice passed sine wave. And once you go back to where it just has written, then you will get clicks. So it can only oscillate between the current write location and the maximum size of your buffer. So I will now put a few steps on the slide, and that is what I will end with today, and then you can see how far you get. We have first the delay line, which is a private variable of the processor, and it's the vector float type. We need to initialize it using the dot resize. So whatever you call your vector, if you call it delay line, you need to call delay line dot resize of a certain integer number. So how many indices is my, or what is the size of my internal buffer, or my delay line? Then in the process block, we need to save input samples to the delay line at a specified write location, and then we need to read them out from a specified read location. So there's a lot of stuff to think about here. And then we can do this wraparound thing using the modulo operator. And once you get there, I'll help you out. I think after the workshop, I also want to upload a finished implementation of this, so you can also take a look yourself. I think I'll do that next week somewhere, so you have some time to think yourself. And then the extra steps are to make the read location oscillate using a low frequency oscillator. So you use your sine wave to, instead of create sound, generate the index of where we are looking in this buffer. So there's some thinking involved there as well. And then finally, add the sliders from what you have learned to control the depth and the frequency of this LFO. With the depth, I mean how far do we look back? And with the frequency, I mean the frequency. So that is it. Please continue to ask questions also online in the QA about this, about what we have covered so far. Yeah, I'll be here until 12 to answer your questions. Yeah, I think learning JUCE in 3 hours is not possible. So like this stuff you don't have to do in the time of the workshop, obviously, but it's just to get you going and trying to find out what else can I do. There's a lot of stuff to add here. So for example, we're not using fractional delays yet, because you will probably hear some clicking in the back and forth of the LFO. For which you can use a fractional delay. But yeah, this workshop was just to introduce you to what JUCE can do, how to locate your sliders, to have you see some grasp of what you can do with the plugin template, at least. And the template itself is also not the most easy one. Like normally I use the audio application template, so you don't have the split between the editor and the audio. So that is just in one file. But it's nice to end up with a VST, I thought. maybe before more people leave the webinar, thanks for a nice workshop. I hope you had an okay time. It didn't go too fast or too slow. Let me know in the comments below or in the Discord channel. If you need more help, I'll be available at this address. And then you will be able to email me with any questions, and we can try and figure it out. But the meeting was also recorded, so we will put that on the conference website or on the NordicSMC website, so you'll be able to rewatch it. Again, the slides are on the Discord channel, so you have all the material you hopefully need to continue using JUCE. So thanks for today, and have a great conference.